Hola, buenas tardes, buenos días a todos.
Hello, good afternoon, good morning to everyone, depending on where you are. Here in Spain, it is 4 p.m. Welcome to everybody to this webinar offered by AGROVIN, which is a company specialized in enological products. My name is Alicia Perez. I'm the communication responsible person of AGROVIN, and on our behalf, I would like to thank you for your time here. We know that this is the holiday season and the harvest is starting, so it is complicated to devote some time to this. Before everything else, please let me give you some indications. It's going to be 1 hour presentation. After that, we will have a Q&A session. I would ask you to kindly use the chat to ask your questions by written. We will try to answer as many questions as possible at the end, and either we will um, upload it in the website. This webinar is going to be recorded and it is going to be posted on AGROVIN's website. And I would like to say that the presentation is going to take place in Spanish, and we will have simultaneous interpretation to English, Italian, and French. Okay, now without further ado, please let me introduce you to Mr. Luis Cotanda, who is the person that is going to speak about the applications of chitosan during harvest. He has a degree on enology with 15 years experience. You have the floor, Luis. Thank you. Thank you. Welcome to this seminar. We will start speaking about the presence of microorganisms in the grapes and how these microorganisms can develop during the first phases of fermentation. Then we will see what are the possible problems that can be originated by these microorganisms. Then we will explain what is chitosan, what is its structure, and why its antimicrobial effect. And then we will speak about the use of chitosan, some aspects that I think will be interesting to know. Finally, we will see some applications of chitosan in the previous phases to the winemaking. Then we will see its use in the multiplication of yeasts, and then we will give a proposal of a product to substitute or replace fully the sulfur dioxide. The first thing I would like to mention is the importance of getting to know the health state of grapes in previous years, such as in rainy days, such as the previous year. In Europe, there were some attacks by fungi that released some must in the cluster or the bunch, and we know that must is a wonderful culture means for a lot of microorganisms. It is known that the microbiological load of a healthy grape is around 100 cells per gram. However, when this grape is attacked by some type of fungi in the must, it has a population that can reach 10 powers 8, which means that the microbiological load of one contaminated grape is the same as the one held by a ton of healthy grapes. These microorganisms that are naturally present in the grape are going to develop during fermentation at a variable speed depending on the pH, the sulfur dioxide temperature, and also depending on its initial population. The higher the population, the faster their development. And this is the case of Saccharomyces, non-Saccharomyces yeasts. which is an organism that is present in the grapes in the highest amount. And their initial presence can be high. They start their development, but the moment that Saccharomyces starts to develop and produce alcohol, the non-Saccharomyces population is going to be reduced. On the other hand, the bacteria, in this case lactic bacteria, which are also present in the grapes, the same as the non-Saccharomyces, can be developed at the beginning of fermentation when the alcohol degree is not a high one, and when the Saccharomyces strain is not implemented, but they stop developing during the fermentation. Then we have also the Ascetic bacteria, which in a lower level than the lactic bacteria are also present in the bunch or the cluster, and they are going to have some more difficulties to develop because they need oxygen or a high redox potential to be able to develop. And in the case of fermentation, the oxygen practically is totally consumed and the redox potential is very low. But when fermentation is finished, then those microorganisms that were able to develop a little before the fermentation and after resisting alcohol are going to develop further in the wine. And this is the case of lactic bacteria, some Ascetic bacteria, and also some non-Saccharomyces, such as Brettanomyces. Then what are the problems of these types of microorganisms? In the beginning, the non-Saccharomyces yeasts that are highly concentrated in the grapes, both healthy and attacked grapes, apart from the fact that in their sugar consumption they produce acetic acid. It is important also to bear in mind the consumption of certain nutrients, not only sugar, because sugar is not greatly consumed at the beginning, but they can also consume some nitrogen and other very easily assimilable compounds and thiamine as well. Lactic bacteria, on their hand, they can produce acetic acid and acetaldehyde, and they can produce diacetyl with a characteristic buttery aroma, and also biogenic amines or amines. Well, normally we think about stamina because it provokes some harm to health, like allergies, etc. But there are other amines like putrescine and cadaverine that affect greatly the perfection of fruit. And then last but not least, the acetic bacteria, and you know what they produce. And apart from these compounds, many more are known to be able to combine with sulfur dioxide, and some of them are produced by microorganisms. We know, for example, gluconic acid. We know that grapes attacked by botrytis have very high levels of gluconic acid, but also pyruvate and acetaldehyde. And if the levels of these compounds are high, then it is going to be very difficult to reach the desired level of free compounds. And then you know that the life of these wines are going to be complicated, and it's going to be difficult to get free sulfur dioxide, and in many cases they need to overcome to exceed 150 milligrams. And in terms of the vitamin consumption or thiamine or vitamin B1, this is necessary by microorganisms to produce energy. And these autochthonous flora coming in with the grapes consume thiamine very quickly, and therefore this thiamine is not available for Saccharomyces cerevisiae, and it is not available for pyruvate and acetaldehyde, and therefore the preservation of the wine with sulfur dioxide is going to be complicated. And one of the microorganisms that is of high concern is also the non-Saccharomyces, the Brettanomyces. You know the main effect, which is the production of ethyl phenols with characteristic aromas, but they can also produce other compounds that will affect the quality of wine. For example, the acetic acid with the aromas of putrid or rot decay, and also the flavor similar to mice. But also they produce sterases that are esterases that are the first effects of the contamination with Brettanomyces is the loss of fruity flavors. And in fact, this is one of the first symptoms that can be noticed in the first phase of the wine contaminated by Brettanomyces. So the first phase would be the loss of these fruity flavors and then the production of ethyl phenols. The development of Brettanomyces is a slow one, and but it is always ongoing. I mean, progressive. And one of the main characteristics of this microorganism, which gives its resistance, is that it can get energy from different carbon sources in small amounts. It is known that with 0.3 grams per liter of residual sugar, Brettanomyces is able to produce ethyl phenols. And in case there is no sugar available, they can use sugars that derive from yeasts during their autolysis, or even degrade or use cellulose as a source of carbon. As a scheme, and taking into account what I just said, this is a scheme on the development of Brettanomyces and also a scheme of the development of lactic and acetic bacteria. In principle, their population in terms of grapes is not a great one. In this first phase of their fermentation, there can be a little development, not with troublesome levels, but it is when the alcoholic fermentation ends, when yeasts are not dominating the medium or the environment or the wine, then it is when Brettanomyces starts to develop. If in the period between the alcoholic and malolactic fermentations, where the level of sulfur dioxide is very low, these populations are not controlled, then they can pose problems in the future, especially if during the malolactic fermentation Brettanomyces stops its development, then the populations can be reduced. But after that, Brettanomyces can continue developing if we don't control it slowly, but progressively, gradually, and in an ongoing way. And therefore, we could have some problem there. Yes. When we speak about chitosan, it has been authorized in Enology for some time. You know that it is a derivate from chitin or chitin. And well, the authorized one is the one that comes from fungal origin. But this molecule was discovered more than 150 years ago. And the production process starting from chitin or chitin, depending if it's American or British English. Well, the process was patented some 90 years ago, and it is known because of its low toxicity, because it affects, it has very low impact on living beings, and these are the reasons why it has been widely used in phytosanitarian products, also in the production and conservation of foods. It has been used for a long time in for filtration or water filtration and water purification, and its use in medical applications has been more recent. But last year, the FDA approved the use of chitosan in some dressings and some gauzes so as to prevent some infections. And therefore, what are the properties of these of Chitosan? Well, it is a non-allergenic product, ecologically authorized, which has high load based to the wine pH, and it is able to react with the membranes of some microorganisms, and it has a very high flocculant power. In fact, chitin or chitin, it is a biopolymer that is present in the exoskeleton of insects and in some microorganisms, and there it's when it is deacetylized, then the amino group becomes terminal, and then it produces chitosan. Why it is interesting to have the amino group in the terminal position? Because when the wine has pH lower than 5.5, then the charge will be a positive one. It will take one proton and it will have a positive charge or load. And this positively charged proton is going to allow it to join aminos and also other molecules that have a positive charge are also able to join other molecules, but they don't have this microbial antimicrobial effect, and this is why chitosan is so effective. It has biocompatibility. The mechanism differs depending on the compound, but basically chitosan is able to introduce itself within the or inside the membrane of cells, and then this is how it works. Basically, in a first phase, because of hydrostatic attraction, it adheres to the membrane of the non-Saccharomyces yeast molecule or cell, where it gets to the membrane proteins, and it alters the structure of this membrane, and it is able to get inside the cell, to introduce itself, to penetrate the cell. Then it generates some pores that modify some essential elements in the cytoplasm, and it alters the functioning of some enzymes, and it can even alter the genetic material of the cell. We will see this better in the next image. On the upper part, on the right, on the right upper side of the screen, you will see some healthy cells with no treatment, and on the lower part, you will see that chitosan has adhered, has stuck to the outside of the cell, and it has created those pores, and it has provoked the loss of genetic material and cytoplasmatic material. You can see in the left-hand side photograph, you can see a cell of a fungus, and due to the chitosan, the restructuring of the membrane has created this hole, and therefore leading to the death, the cell death. In the case of the gram-positive bacteria, the mechanism is really similar. It, due to electrostatic attraction, it joins the cell wall and it alters the membrane, and it provokes the exiting of the cytoplasmatic content. And the same as we saw the previous images, on the top part, on the right-hand side, you see healthy cells with full membrane, and on the lower part you see how, due to chitosan, these membranes have broken down and the cytoplasmic content has gone out of the cell, provoking cell death. Chitosan is able to provoke cell death, as we said, but it has a very strong microorganism flocculant effect. It can join microorganisms, form aggregates that are big enough and with low charge, so that due to the gravity, they get to the bottom of the deposit of the tank. The question would be, is it necessary to proceed to racking? Is it necessary to rack, or can we resuspend? Well, clients have come to us to ask us about it, and we decided to perform a little test. We performed a treatment with chitosan, where you can see the two plates on the right hand side. Well, the two ones on the left hand side were treated so that they would enhance the antifungal effect. And after 15 days, we racked the supernatant, and after some days in contact, we decided to culture in an isolated way the upper part, the clean part, free of chitosan, and then on the other hand, the part that was having the leads, the chitosan leans. And after the culture on a plate, we saw that the supernatant in the clean part was totally yeast free. However, the lower part, the bottom, was having yeasts, and this is why we in AGROVIN we recommend to rack wine after 15 days after having used chitosan. So now we're going to speak about the applications. We've seen that the microbiological load of cells and musts can be high. Why then should we treat these musts or the wines before the fermentation with chitosan? In the first phases, we've seen that the must conditions are rather favorable for the growth of many microorganisms, such as the non-Saccharomyces yeasts that can reduce essential nutrients or some growth factors that are essential for the yeast, and therefore we can create difficulties to the development and the growth of these of Saccharomyces, and therefore when we sow Saccharomyces, the medium can be poor in some oligo elements, and therefore we can put some difficulties to its development. This development by Saccharomyces in difficult conditions can lead to the development of lactic bacteria, and therefore we will see the start of malolactic fermentation at the same time, or maybe those yeasts would not be strong enough so as to finish fermentation, and therefore that would be a case of stuck and sluggish fermentations. And we can also see the use of metabolites that are, the increase of metabolites that are easily combined with sulfur dioxide. Therefore, in terms of applications, we should use chitosan during the maceration of white grape, normally at a low temperature. The non-Saccharomyces have the evolutionary advantage of being able to function well at low temperatures, and otherwise we can perform a pre-fermentative maceration or add it to the pressed must or the clean must. And for this application, we have developed the MicroStab pH, which is a liquid product, and therefore the application is really easy because of its liquidity. And we also favor dispersal of chitosan, which is necessary to obtain a good effect. And in fact, this product has been specifically designed to use it in the harvest, or even use dosification systems such as the Pixis, which is the line dosification system that we have for the treatment of musts. On the other hand, it is formulated at a very highly acidic pH, that is a very low pH, because we've seen that in these conditions, chitosan is very soluble, and therefore we can also reduce the pH in the must, and therefore we put some difficulties to the development of microorganisms, and also it favors the effect of the sulfur dioxide. When we decided to test this product, we thought that it would be interesting to control the lactic bacteria, and therefore we harvested lactic bacteria in a must, and we waited for 24 hours so that the bacteria would get comfortable, let's say. And we performed a treatment with chitosan, and after 24, 48 hours, the bacterial population was low enough so as to be sure that the malolactic fermentation would not take place. We wanted to see its effect against Brettanomyces, and therefore we harvested the must with Brettanomyces and we inoculated it in a must, and we saw that it was very effective. After the treatment, we could not detect Brettanomyces at all. As we have seen, if the health quality in grapes is going to determine the amount of microorganisms that we have present in the must, this will enable us to measure or know what are the dosages that we need to use. Gluconic acid is a parameter that for some years is being measured regularly in wine in cellars or wineries, because they use it as a measure to see the quality of the wine. And when you have in healthy grapes, you have gluconic acid under 0.5 grams per liter, a dose of chitosan between 50 and 100 milliliters per 100 kilograms, that would be enough in the maceration. I mean, in case we have grapes attacked by fungi, and when the gluconic acid is present at concentrations higher than 0.5 grams per liter, then during the maceration we should apply chitosan 150 or 200 milliliters per 100 kilograms. In continuing with the applications, in the case of very quick press, we can add it in to the must. In static debourbage or in static settling, we need to give some time to chitosan for this antimicrobial activity. But in the cases of active or dynamic, debourbage or settling, notwithstanding the system, the dose can be a bit lower because we know that the floating is going to reduce the biological load. So in the first case, it would be 100 milliliters per hectoliter, and in the second case, the flotation case, it would be 50 milliliters per hectoliter. So if we have been using in maceration or in must to prevent chitosan to prevent the development of microorganisms, in the case of having some stuck or sluggish fermentations, the populations of microorganisms are not going to be high enough so as to have an immediate problem, which means that if we have treated the musts or the maceration grapes with chitosan and we have slow down or a sluggish fermentation or a stuck fermentation, we can be convinced of the fact that either we wait until the yeast reactivates due to nutrition, or we can perform a fermentation protocol, but being sure that the microorganisms present in the most must are not going to be troublesome. But in the case that we have not used pH as a preventive measure, we can use it as a post preventive measure, and in that moment we can add chitosan and we can correct the pH, and with chitosan we will remove the remaining microorganisms either by handling the deposit by itself or with a re-fermentation protocol. In the case of white wines or rosé wines, as we don't want to have the malolactic fermentation, 150 milliliters per hectoliter would be enough. In the case of red wines, if we want to have a malolactic fermentation afterwards with a dose of 50 milliliters per hectoliter, it is going to be enough to have time enough to act, and it is not going to give us problems when we harvest lactic bacteria afterwards whenever we carry out racking um, in that case. and then we would have a post-fermentative maceration. If the grape has stopped fermenting, so as to be sure that there will be no development of lactic bacteria with the problems that there would be a fermentation at that moment with the skins and everything, we can add 50 milligrams 100 kilograms, and with this we will be sure that there will be no development of microorganisms. Another application of chitosan before fermenting would be the multiplication of yeasts. I would like to sum up very simply the different phases of yeast multiplication during standard fermentation. In this graph, you can see the evolution. In principle, we harvest the yeast, then there is a latency phase, the length of which, or a lag phase, the length of which is going to depend on the temperature, the sulfur dioxide, and also the strain chosen for fermentation. So during this phase, the yeast is going to get ready for the new conditions. Then there is an exponential phase, which is when the yeast is going to start multiplying exponentially up to the moment that it achieves the maximum population that is going to conduct fermentation, so or carry out the fermentation, and then there will be a stationary phase when the yeast is not going to reproduce any further, and it has to bear the whole fermentation until the sugars are deployed and the cells die. What characterizes exponential phase is a great resource consumption. Then the yeast needs to create all the necessary biomass to multiply by several hundreds its own population. And what happens in a multiplier when we use this type of systems to multiply yeasts in the winery? Well, the scheme is a similar one, but the difference is that we're going to demand two exponential growth phases from the yeast, one in the multiplier and the second one in the tank where we are going to send it. I don't mean that yeast multiplication is a simple thing, but when we have those yeasts that are multiplying and are feasible, that is, they are able to finish the fermentation, that requires a certain level of nutrition. And this is why some nutrients specific for nurturing this type of systems, intensive systems, have been designed, um, including autolysis of yeasts and source of inorganic or non-organic nitrogen, because we need this nitrogen to be incorporated very rapidly, very fast. We know that due to the aromas and to avoid a possible reduction on the fermentation speed, because of the multipliers, we need the nitrogen to be assimilated very quickly. You know that the non-organic nitrogen is assimilated much, much faster than the organic nitrogen. And then we will need also thiamine so as to have a supplement of this vitamin. But we are preparing the environment or the medium for a super multiplication. We are putting at hand all the factors that these microorganisms need to grow. You know that the amount of microorganisms here can be very high. What did we see in AGROVIN when we were looking for the design of a specific nutrient for such complicated conditions? Well, in our laboratory, we conducted some tests so as to determine what kind of nutrition produces this biomass. With such a nutrient, we saw that there was a considerable increase in the population of yeasts to the necessary levels in a multiplier, but we also realized that not only the yeasts were growing, but other microorganisms were also growing. In fact, there was a very important growth of lactic bacteria, and we also saw that the non-Saccharomyces yeasts were the presence was also high. In this test, well, we conducted several tests. In one of them, we used the clean must of the winery, and then we also tested with concentrated must, and we also saw that there were some contamination problems even using this type of must, even though the contaminations were lower, of course. And due to all this, we decided to use chitosan and add it to the specific nutrient design for the multiplication. Of course, firstly, we perform the autolysis of yeasts with high content in sterols, such as ergosterol and mineral salts that are non-exogenous ones, and they can use it if they are under the form of inactive yeast. Then we also added non-organic nitrogen as ammonia phosphate, and also thiamine, which guarantees the a content enough of vitamin B1 so that the yeasts can get their energy. And then we added fungal chitosan. And what we saw was that after some tests, we had the growth of the yeasts that we needed for the application in multipliers, but we also saw that the lactic bacteria could not develop. In fact, we did not detect the presence of lactic bacteria after 16 hours of multiplication, and we also saw that these non-Saccharomyces yeasts were significantly reduced. Summing up, what would be the advantages of applying these types of nutrients in multiplication? Well, we have a very quick development of yeasts with viable, feasible yeasts that are able to finish fermentation with no problems. We will see that yeast that we have multiplied will be able to express itself. It is going to be imposed in the second fermentation that we have subjected it to. And then another application of or advantage of chitosan is that it allows us to reduce the amount of sulfur dioxide that we use. We know that the market and the consumers are making things difficult for us in terms of sulfur dioxide. And then there is a fashion for wines with no sulfur dioxide. We know that chitosan works very well, even considering the reduction of microorganisms. But my question is it an alternative to sulfur dioxide? Well, when we use chitosan, we want to reduce the use of sulfur dioxide. But what happens with oxidation? In AGROVIN, we have designed MicroStab Protect to cover the needs satisfied by sulfur dioxide and anhydrous compound. And we have the antioxidant protection given by the and glutathione, sorry, and it also protects the aromatic fraction because of this natural antioxidant effect, and it reduces the activity of oxidative enzymes responsible for the phenol oxidation. We saw that with a dose of 20 grams per hectoliter, that was enough. We were able to cultivate and that treated wine, and we could not find Brettanomyces. And we performed another test with lactic bacteria with the same system. We harvested lactic bacteria. We gave 24 hours time, and we treated with Stab Protect with sulfur dioxide, and the result was that after the first week, obviously there was no development in the treated wines, but the second week there was no development of bacteria. There was no reduction of the malic acid and therefore no bacterial activity in the sample treated with microstab protect, but the malolactic activity had started in the sample treated with sulfur dioxide. So 3 weeks for 3 weeks, microstab protect was effective against the development or for the development of lactic bacteria, but not in the case of sulfur dioxide. And then we have the antioxidant activity. We know that we combine glutathione with gallic tannin, and we achieved the fact that the product would be even more efficient than sulfur dioxide. We conducted our tests on white wine with an accelerated fermentation with help of a stove, and we measure the increase of the yellow component, that is the browning color of wines, and we saw that microstab protect was more effective than a treatment with 30 milligrams per liter of sulfur dioxide, and it was even more efficient than the equivalent dose of glutathione. So we saw that thanks to the antioxidant properties combined with the chelating agent, the chelating activity of metals, we were able to achieve a product that was much more efficient than the sulfur dioxide. And I would like to comment on a couple of less known factors or effects. If you see the graph on the top left, we always thought that pH was a limiting factor for life because under a certain pH, organisms would not develop or would develop very little. But we saw that it is not only pH, but also the electrochemical or redox potential also influences this development. We know that for every organism, there is a redox potential under which this organism cannot progress, cannot develop. We know that fermentation will stop under a certain redox potential because the yeast is not able to develop under this redox potential. So, under the same consideration, I would like to speak a little bit about ascetic bacteria. As I mentioned at the beginning of the presentation, ascetic bacteria need oxygen and need a high redox potential to be able to develop. I don't know if I mentioned this, but we do know after some studies and tests that chitosan is not effective against ascetic bacteria. So what did we achieve with microstab protect? Due to its glutathione, we have achieved to reduce the redox potential of the wine, and therefore we have put some barriers to the development of lactic bacteria. If you want to know more about the redox potential, we held a webinar a month ago that is available at agrovin.com and in our website. So as to sum up my presentation, we have seen how the amount of microorganisms that can be existing in the grape can be variable and depending on different factors, but mainly the health of the grapes, the healthy state of grapes. We've seen that these microorganisms can develop in the winery depending on certain parameters. We've seen also the type of problems that these microorganisms can cause. And then we have spoken about chitosan. How we have seen that it is a molecule able to adhere to microorganisms and able to alter their metabolism, altering their membrane and provoking the cell death and the flocculation. we've seen that flocculation, in the case of flocculation, it is very important to rack after every one of the treatments performed with chitosan after 10 or 15 days. And then we have seen how um, by applying pH before the fermentation, we can have a more microbiological clean must, avoiding some problems during the fermentation and limiting the development of microorganisms after the fermentation. Then we spoke about multipliers, and we've seen how the optimal conditions of multiplication in a multiplier are facilitating the multiplication of yeasts, but not only this, but many other things. And we have seen how with Actimax regrowth, the selected yeast is going to be multiplied much further. And we finished by presenting an alternative to the use of sulfur dioxide, combining the antimicrobial properties of chitosan with glutathione that is giving us this extra protection that we need during the whole winemaking if we want to reduce the level of sulfur dioxide. Well, I have finished with this. This is the end of my presentation. And of course, if you have any question, I would be more than pleased to answer it. Okay, well, Luis, we are going to stop. We have many more questions, and as I was saying at the beginning of the webinar, do not worry because we will answer all the questions and we will upload the answers in our site. Thank you very much, Luis, for your presentation. Thank you because your presentation has been very, very interesting. Thank you to all the audience because of the time that you have devoted to us. And of course, if you have any question about Kaito-san or you want to contact us, please do not hesitate to contact us. You have our email address and our telephone number here on the screen. Thank you very much. I would like to wish you good afternoon, good summer, and good harvest.